Hey everyone, so in this unit we're going to be talking about inverse functions. So the basic idea of an inverse function is just an opposite function. We've talked about inverse operations, so if I'm trying to solve some simple algebra, I've got x plus 2 is 4. So if I need to get x alone here, I can do the opposite, the inverse operation, which would be to subtract 2, since we have right now x is being added to 2. All right, now show me my answer. An inverse function is the same idea where we want to find the opposite set of operations. So for example, let's say f of x right here. This function was to take my input and add 2. Then the opposite function, the inverse, would be to take my input and subtract 2, just the very opposite. So if x were 5, it goes through the first function, we add 2 to it, we get 7. Then we go through the next function, we subtract 2, and we're back to 5. That's the basic idea behind an inverse function. When we graph an inverse function, we get some pretty cool symmetry. So we can take any function and find its inverse relation. For example, this function, this cubic function, has an inverse relation that looks like this. Notice that to find my inverse here, all I did was swap out my y for an x, and all of my x's I swapped out for y's. But you might notice that this red function, this red graph is not a function. It fails the vertical line test. So we can always find an inverse relation, but we won't always necessarily have a function when we get there. So that's the basic idea of an inverse is we're finding the opposite operation. So the main focus today is to try and find inverses algebraically. So I have sort of a step-by-step for you in the notes. The basic idea is we want to first start by looking at our function, thinking about what would it look like graphically. So this first function on your notes is the square root of x minus 4, which would look like this guy, this little red guy here. And I want to think about what my domain and range will be. And then to find the inverse, all I did was I swapped out x and y. And on Desmos, that's fine. We just swap x and y, and Desmos can figure out how to turn these inputs into outputs. But typically when we write functions, we don't want to leave it in that form. We want an output by itself. So we can take an input, have a rule that we do to the input, and get an output. So once we swap out x and y here, we want to actually solve for y. So you can take a closer look at this on your own. But basically the idea here, we solve for y, we square both sides, we add the 4, all right, go through those inverse operations until y is by itself. So we can see the opposite of this function, the square root of an input minus 4, is to square an input and add 4. It makes sense that those are opposites. When we graph this though, we aren't going to see just this little dude up here that we'd expect when we flip over that line y equals x. So it can also be really important here to define your domain and range. And this is only in certain cases where we have to be really strict about this, but if we think about it, our initial function, the original f function, was this little square root guy, which doesn't have any negative outputs. All right, the square root function has no negative outputs. So when we find the inverse of this, we don't have any negative inputs. So you might find that when we graph these two functions, and we just proved algebraically that these were inverses, they don't look like inverses. It doesn't look like a reflection from here to here. And again, that's a reflection over this diagonal line y equals x. We have to specifically say that the inverse of the square root of x minus 4 is x squared plus 4, but we want to restrict that to only being x's greater than 0. And now we see what I had on my sketch, hey Shu, which is an actual reflection over that inverse. Okay, so let's take a look at your homework for this day, which is matching functions with their inverse. So I've got the first one shown for you here. Let's take a look at the next guy. So what I want to do here to find an inverse is I take my function, set it up in plain old y equals form, and then I swap out x and y. Once I do that, I just need to solve for y. So I'm going to do a couple examples for you. Cool, so I'll take this first one. G of x is 1/4 x squared. So g of x is equal to 1/4 times x squared. Now, the function notation is fantastic. It's what we're going to be using, but just to simplify things, we're going to change that back to y. Now, this is my function, g of x. I just changed the notation back to y. It means the same thing as the output here. So the first thing we want to do to find an inverse is to swap out x and y. So x is 1/4 y squared. Notice nothing changes places except for our variables. So that 1/4 stays here, the squared, everything stays, coefficients, exponents, everything stays except for x and y. Okay, so now my goal is to actually solve this equation. And when I solve, I mean get y by itself. So there's a couple things happening here. We're multiplying y by 1/4 and we're squaring it. So the first thing I probably want to do here is get rid of that 1/4. So the opposite of multiplying by 1/4 would be multiplying by 4. All right, if I multiply 4 times 1/4, I get 1y squared, which is what I want. So that means on the left side I've got 4x. Okay, now I've got y squared, and I want to get rid of that square, so I do the opposite, which is to square root it. It's the opposite of a square, square root. So we get y is the square root of 4x. Cool. So the inverse of g of x, so we could, if we wanted to be fancy here, we could write our inverse notation. So g inverse of x would be the square root of 4x. So on your worksheet, you're going to try to find the square root of 4x. Looks like C is a match for G. So we get another DNA match there. Okay, let's take a look at another one. Let's try W of x. So W of x is 4x plus 2 squared. Four x plus 2, and I think the whole thing was squared. Let me double check that. Yeah. Okay, cool. So again, we start by getting this into y equals instead of our function notation, just so it's a little easier to work with. And then, to make this an inverse, we swap out x and y. Okay, so this is my inverse function. This is the right answer, kind of. But when we write a function, we should have the output by itself, so that we can think of it as a rule, something we do to our input. Okay, so the first thing we need to do is take care of that square. We want to get rid of a square, and we just said a moment ago, the opposite of a square is a square root. So I'm going to square root both sides of the equation. So I get the square root of x is equal to 4y plus 2. The square root and the square, they cancel each other out. Okay, so we're getting closer. We want y by itself, plain old y. I don't want this plus 2 anymore, so I do the inverse operation. I subtract 2. So now I've got the square root of x minus 2. Notice that these are not like terms. These are unlike terms. We can't put them together. Y is almost by itself, but now we're multiplying it times 4. I want to undo that, so I divide by 4. Notice I divide the whole left side by 4. So we get y is the square root of x minus 2 all over 4. Maybe we could write this as square root of x over 4 minus 1/2, but that's a little messy. Let's see if we can find this on our worksheet. So we're looking for square root of x minus 2 over 4. There we go. Looks like that's a match with y. Okay, I'm going to do one more here as an example. Let's do one with a square root here. So how about let's do j. All right, so j was the square root of x plus 2 over 4. Let me just double check I got that right. Yep. Okay. So again, that j of x function notation is nice, but it's kind of hard to work with when we're going to do some algebra here. So I'm going to replace it with y, another name for our output. And then I'm going to swap out x and y. So x is equal to the square root of y plus 2. Notice the only thing changing place here is my x and y. Okay, so there's a lot being done to my y. I'm adding 2 to it, I'm taking a square root, I'm dividing by 4. We could try to square both sides first to get rid of our radical, and that would work, but we'd also have to square that denominator. Everything's got to get squared. So actually, I think I'm going to multiply times 4 first. And it doesn't matter. We can get the right answer. As long as we follow our algebra logic here, we can get the right answer even if we go in a different order. So I multiplied by 4. So times 4 and divided by 4, they cancel each other out. They're inverse operations. Now I'm going to get rid of my radical. That's the square root symbol. The opposite of a square root is to square. So I'm going to square both sides. You want to be really careful here. The square root and the square cancel out. We got y plus 2 here. But then on the left side, you got to make sure you square everything. So that 4 is going to become a 16. And then x squared. Can you not? Okay. Last thing I'm going to do here, I got this plus 2 with my y. I don't want that, so I subtract 2 from both sides. So we get 16x squared minus 2 equals y. So that's what I'm looking for. My inverse should look something like this. 16x squared minus 2. So 16x squared, there's a 16x squared, but there's a minus 2 on it. So I'm not seeing my answer exactly. All right, there's a 16x squared, but there's no minus 2. I know I have a minus 2 here. Ooh, what about p? So this doesn't look exactly like my answer, but maybe that's the same thing. 4x, the whole thing squared, minus 2. Well, yeah, that works, because look, 4x, the whole thing squared, is 16x squared. So those are equivalent. And you'll find this on the homework, that you might see something written in a slightly different form than you're used to, or that you write down, but it doesn't mean you're wrong, right? We might have a slightly different answer. I like my answer better, right? Because it's more simplified, but this is what I saw on my worksheet. So don't get frustrated if you think you have the right answer and you can't find it exactly. There's a few in here that are in a strange form. For example, r of x, not sure why they went with this. Much simpler, simplified version would just be 4x squared. All right, so take a look at this. Find your matches. There's a couple for you to get started. And as always, you come see me in person if you need some more help. Thanks, y'all.